everyone. Welcome back. Today, we're diving into one of the most mysterious and mind-bending topics in modern science: dark matter and dark energy. These are the invisible forces that make up the vast majority of our universe, yet we still know almost nothing about them. Imagine trying to understand a puzzle where over 95% of the pieces are hidden. Sounds tricky, right? In this episode, we're going to explore what dark matter and dark energy are, or might be, how we discovered their existence, and why understanding them could change everything we know about the universe. Before we get into dark matter and dark energy, let's set the stage by talking about what we can actually see: the visible universe. This includes everything we're familiar with: stars, planets, galaxies, and even the space between them. All of this normal stuff is made up of baryonic matter, atoms that combine to form the elements we know, like hydrogen, helium, and carbon. Now here's the mind-blowing part. Baryonic matter, the stuff we can see and interact with, only makes up about 5% of the universe. That means the rest, 95%, is something entirely different, something we can't see, touch, or even fully understand. This is where dark matter and dark energy come into play. Let's start with dark matter. Scientists believe that dark matter makes up about 27% of the universe. It doesn't emit, absorb, or reflect light, which means it's completely invisible. So how do we even know it exists? The story of dark matter begins with the movement of galaxies. In the 1930s, astronomers noticed that galaxies were spinning much faster than they should be if they were only made up of visible matter. According to the laws of physics, galaxies spinning that fast should be flying apart, but something unseen was holding them together. This invisible glue was eventually dubbed dark matter. One of the best pieces of evidence for dark matter comes from something called gravitational lensing. When light from distant galaxies passes near a massive object, it bends, kind of like how light bends when it passes through a lens. Scientists noticed that the amount of bending couldn't be explained by visible matter alone. There had to be something else, an unseen mass that was bending the light even more. But what is dark matter made of? Well, that's still one of the universe's biggest mysteries. Scientists have a few theories. Some think dark matter might be made up of weakly interacting particles, known as WIMPs, that barely interact with normal matter. Others propose particles called axions. But despite years of searching, we still haven't directly detected a single dark matter particle. If dark matter sounds mysterious, then dark energy is even more so. While dark matter holds galaxies together, dark energy seems to be doing the opposite. It's driving them apart. Dark energy makes up a whopping 68% of the universe, making it the dominant force out there, but it's even harder to understand than dark matter. The discovery of dark energy came in the 1990s when astronomers noticed something strange. The universe wasn't just expanding, it was expanding faster and faster. This was surprising because, according to the laws of physics, the expansion should be slowing down due to gravity. Instead, something was pushing galaxies apart at an accelerating rate. So, what exactly is dark energy? One possibility is that it's a property of space itself. According to Einstein's theory of general relativity, empty space can have its own energy, which could cause the universe to expand. Another theory is that dark energy might be linked to a new field or particle that we haven't discovered yet. But the truth is, we still don't fully understand what dark energy is or how it works. It's one of the most profound mysteries in cosmology, and solving it could completely change our understanding of the universe. You might be wondering, how do we study dark matter and dark energy if we can't see or touch them? Great question. The answer lies in indirect evidence. For dark matter, scientists study its effects on visible matter, radiation, and the structure of the universe. As we mentioned earlier, dark matter's gravitational effects on galaxies and light give us clues about where it is and how much of it there might be. Studying dark energy is a bit trickier. Scientists look at the rate of the universe's expansion over time by observing distant supernovae, which are massive stellar explosions that act like cosmic mile markers. These observations help scientists measure the acceleration of the universe's expansion, giving them insights into the effects of dark energy. One of the biggest tools for studying dark energy is the cosmic microwave background, CMB, the afterglow of the Big Bang. By analyzing the CMB, scientists can learn about the early universe and how it has changed over billions of years, offering clues about the nature of dark energy. The hunt for answers has led to some fascinating theories and hypotheses. For dark matter, scientists have proposed a few possibilities. One is that dark matter could be made up of WIMPs, weakly interacting massive particles. WIMPs don't interact with light or normal matter in a way we can detect, which is why they're so hard to find. There's also a theory that dark matter might consist of particles called sterile neutrinos, which are similar to regular neutrinos but don't interact via the weak nuclear force. On the dark energy side, one idea is that it's linked to Einstein's cosmological constant, a term he introduced to account for a static universe, but later abandoned when the expansion of the universe was discovered. The cosmological constant could represent a constant energy density that fills space, driving the accelerated expansion of the universe. Another hypothesis is that dark energy might be the effect of a new type of scalar field, similar to the Higgs field, that permeates space and causes the accelerated expansion. Yet another theory is that dark energy might be evidence of extra dimensions or even signs of a multiverse. Understanding dark matter and dark energy isn't just about figuring out what they are, it's also about understanding the future of the universe. The presence of dark energy, in particular, has huge implications for how the universe might end. If dark energy continues driving the expansion of the universe, we could be heading toward a big freeze, where galaxies drift so far apart that they eventually disappear from each other's view, leaving a cold, dark, and empty universe. Another possibility is the Big Rip, a scenario where dark energy's repulsive force grows stronger over time, eventually tearing galaxies, stars, planets, and even atoms apart. Then there's the Big Crunch, a theory that suggests dark energy might reverse, causing the universe to collapse back in on itself. Although this scenario is less likely with what we currently know, it's still a theoretical possibility. You might be wondering why it's so important to understand dark matter and dark energy. Well, these mysteries aren't just academic. They're key to understanding the very fabric of our universe. For one, dark matter and dark energy shape the way galaxies form and evolve. Without dark matter, galaxies wouldn't hold together, meaning the structure of the universe as we know it wouldn't exist. And dark energy's role in the accelerating expansion of the universe affects everything from galaxy formation to the ultimate fate of the cosmos. Understanding these forces could open up entirely new areas of physics and help us uncover deeper truths about reality. It's like being on the edge of discovering a whole new aspect of the universe, and we're just starting to scratch the surface. So, are we any closer to understanding the invisible universe? In some ways, yes. But in other ways, we've only just begun. Dark matter and dark energy are two of the biggest puzzles in science, and cracking their secrets could change everything we know about the cosmos. But one thing is clear. The journey to understanding dark matter and dark energy is one of the most exciting frontiers in physics. It's a reminder of how much we still don't know and how vast and mysterious the universe truly is. Thanks for tuning in today as we explored the invisible universe. If you enjoyed this episode, share it with someone who loves pondering the mysteries of space. Until next time, keep looking up and stay curious.